Hey guys, welcome to brainAttic. So today we have another very interesting and challenging problem from the topic of trigonometric functions. This question was most recently asked in JEE Advanced 2023. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So as you can see, we are given A1, A2, A8 vertices of a regular octagon that lie on the circle of radius 2. Let P be a point on the circle and let PAI denote the distance between the points P and AI for I equal to 1 to 8. If P varies over the circle, then the maximum value of the product of PA1, PA2 all the way up to PA8. Now, what we are going to do is I've already prepared a uh, diagram where you can see A1, A2, A3 all the way up to A8 are the vertices of a regular octagon. I've marked the radius of the circle as 2 already because it is given to us, and let us call the center of the circle as O. Now, P is at any point between the two vertices and it makes an angle theta in the lower side and angle phi on the other side. This is just an assumption. Therefore, the internal angle of an octagon is always internal angle of an octagon uh, is 45 degrees or pi by 4. So by internal angle, I mean that the angle between the vertices A1 and A2. That is what I'm calling internal angle. Please pardon my nomenclature if it is wrong. So I can very easily say that theta plus phi is always equal to pi by 4. Correct? Now, if you see, I can very easily make a triangle OPA1. So in the triangle OPA1, the angle O is equal to theta. Now, since the side OP is equal to OA1, I can very easily say, which is equal to 2, I can very easily say that the angle P is equal to angle A1. Now, if the two angles are equal, this should be theta, my bad. So if the two angles are equal, I know from the sum of the angles of a triangle that pi is equal to theta plus 2p, or maybe I'll elaborate a little, p plus a1. Now p and a are equal, so I can very easily write this as 2p, 2 angle p is equal to theta minus pi minus theta. Now angle p is equal to pi by 2 minus theta by 2. So now I know what angle A1, angle P and angle O are in the triangle OPA1. I hope this is clear. Now by sine law, so sine law basically says that PA1 by sine theta is equal to 2 by sine 90 minus theta by 2. Pi by 2 is basically 90 degrees. I've written 90. You can also, let's just say, write it as pi by 2, if this works for you. Now, I can very easily do this. PA1 is equal to 2 sine theta by cos theta by 2. Now I know the formula of sine 2a, which is equal to 2 sine a cos a. Okay, applying that formula, what I have now is 2 sine theta by 2 cos theta by 2, and I have the original 2 in front, cos theta by 2. So this cancels out, and what we are left is 4 sine theta by 2. Now we have found PA1. On the similar logic, I can use the same concept and fill up for all the points A1, A8, A7 and A6. So that will be PA8 is equal to 4 sine pi by 8 plus theta by 2. Okay, let us say this is alpha 1 and let us say this is alpha 8. Now going back a little bit more, PA7 is equal to 4 sine 2 pi by 8 plus theta by 2. This is alpha 7. And PA6 is equal to 4 sine 3 pi by 8 plus theta by 2. This I'm calling as alpha 6. Now, a similar deduction I can do with the angle phi. And this gives me similar strategy, nothing different. Similarly, if I do it for PA2, what I have is 4 sine phi by 2, correct, is equal to alpha 2. Now, PA3 will be equal to 4 sine pi by 8 plus 5 by 2. This I'm going to write as alpha 3. Now PA4 is equal to 4 sine 2 pi by 8 plus 5 by 2, which is equal to alpha 4. And finally, what term we are left with is PA5. PA5 is equal to 4 sine 3 pi by 8 plus 5 by 2 is equal to alpha 5. So we have all the distance values with us now. Now the question asks us to find the maximum value of the product of these distances. So let PA1, PA2 all the way, I'm taking the product of this basically, PA8. Let me say, now we have already used the term alpha 1, alpha 2 all the way. Sorry, this is product. Alpha 8, let me call this as M. Now, my M basically looks like this. 4 to the power 8 sine theta by 2 sine 3 pi by 8 pi plus 5 by 2 in product with, these are all product terms. I'm just writing for the space issue. Pi by 8 plus theta by 2 sine pi by 4 plus 5 by 2 sine pi by 4 plus theta by 2 sine pi by 8 pi by 8 plus 5 by 2 product again. We have sine 3 pi by 8 plus theta by 2 and finally sine 5 by 2. So I hope I have not made any mistakes and I have all the terms which are relevant for this problem. Now a simple evaluation will help us ease the problem a lot. So we have already made a constraint. The constraint is that my theta plus phi is always equal to pi by 4. So we'll use this extensively. And now what we are going to do is that we have 4 power 8. Sine theta by 2 is an okay term for me, so I'm not worried. This I'll convert the other term to cos. So what I have now is cos pi by 2 minus 3 pi by 8 minus 5 by 2. It will take some time to solve. So what I'm intending to do, I'll tell you, I'll bring all the terms in the theta format. Theta pi by 2 plus sine theta by 2 sine pi by 2 minus, I'll convert this to cos. Let me use this. Cos pi by 2 minus pi by 4 minus pi by 2. Now, sine theta, I'm fine with sine theta terms. All the terms with theta are okay to me. Sine. Now, this phi term is there, which I'll make to cos pi by 2 minus pi by 8 minus pi by 2. Then eventually I have sine 3 pi by 8 plus theta by 2 sine. Again, there's a phi term, I'll convert it to cos. So I have cos pi by 2 minus pi by 2. So now when you solve this, right, what you are left, I'll directly write the end result. This is mostly calculation from here onwards. It's very easy. So I have sine theta by 2 cos theta by 2 sine pi by 8 plus theta by 2 into cos pi by 8 plus theta by 2 into sine, this is all product actually, pi by 4 plus theta by 2 into cos pi by 4 plus theta by 2, and finally I have sine 3 pi by 8 plus sine 3 pi by 8 plus theta by 2 into cos 3 pi by 8 plus theta by 2. So I have all my terms, relevant terms here. Now what I'm going to do is I will again use the formula which I have already shown it to you, which is sine 2a is equal to 2 sine a cos a. So what I have now is power 16. So if I write this as 2 power 16 by 2 power 4, and this gives me sine theta sine pi by 4 plus theta sine pi by 4 plus theta, and eventually sine 3 pi by 4 plus theta. So I have my terms. Now doing the same exercise again, so this cancels out and this is 12 left. Doing the same exercise again, right? So 2 power 12 sine theta cos theta sine pi by 4 plus theta cos pi by 4 plus theta. And now what I have is 2 power 12 by 2 square, and this gives me sine 2 theta and sine pi by 2 plus 2 theta. So this is my result. Now eventually I can write this as 2 power, this cancels and makes it 2 power 10, and then 2 power 10 by 2, again I have sine 4 theta. So this is what I get eventually. So I'll cancel this out, 2 power 9. So now when does sine theta become maximum? Sine theta achieves its maximum value at 1. So 2 power 9 into 1, and the value maximum for m can be 512. So this is your answer. If you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.